Okay, we're studying logarithms, so I wanted to show you one of the applications. I've asked this 100 times. How many of you are in chemistry? 5 or 6 of us, that's it. Okay. So I talked to Miss Doyle. Those of you in chemistry are going to see this pH scale in the next 2 weeks before spring break, the next 3 weeks. Okay, so it'll be good for you to see it now, work some of the mathematics behind it, and you'll be able to take that with you when you're learning pH in chemistry. But again, this is a logarithmic scale. It's base 10. So these are powers of 10. Okay, it's the concentration of hydrogen ions in the solution. Okay, and I'll show you the formula here in a minute. But basically, 10 to the 0, 10 to the 1, 10 to the 2. We take the log of that to actually give us a nice, easy number to work with on the pH scale. Okay, so each one of these has 10 times more hydrogen ions in it than the last. Right? Kind of makes sense based on what we talked about with earthquakes. It's the same process. We hang out in here a lot as humans. Okay, maybe a little bit down or a little bit up. We can drink a little wine. Well, the adults are supposed to be able to. We use baking soda sometimes when we cook, stuff like that. But if you get anywhere above 10, you're getting into some pretty nasty stuff. Some bases, and then anything, lemon juice actually we use quite a bit, but anything below a 3 or a 2 is really nasty stuff. They'll burn you, make you throw up, vomit, ingest it as bad as. So, of course, distilled water, you know what distilled water is? Mm-hmm. Basically, they take everything out of it except the H2O. Nothing in it. It's a section. Use distilled water in a lot of CPAP machines. Anybody know anybody that has sleep apnea? You have to use distilled water in those machines. Car radiators, actually use distilled water. This heat causes the junk to precipitate out and stick to metal, so you don't want anything in it. So there's nothing in there to precipitate out. There you go, pH. Okay. Pretty handy. I like to grow and process my own food. pH is fairly important because when you can stuff, if the pH is acidic enough, you actually have to pressure can it. Tomatoes are getting to the point where they aren't very acidic anymore, so you have to actually add lemon juice to can them properly, so they aren't disease carrying after you can them. So just a few things that maybe you can use. So the pH common logs, eraser. Common logs are base 10, I told you that. Some of you like this. Stuff of that nature. We'll study also natural logs, which are base E. That's a big Thursday. So those are kind of two big ones.
Wait, will you get to that?
The pH formula is notice I didn't put a 10. If there's no number for a base, it's a 10. That's why we call it a common logarithm. We just call it a log. So no number means base 10. And this is the number of hydrogen ions. So if I have, let's just take the number out of the book. 7.94 times 10 to the negative 9 hydrogen ions, I think it's moles per liter. And again, chemistry folks, you'll learn all about that. What is the pH? You basically stick your number in there. This is a calculator problem. So if you don't have one, you might want to go grab one, because I haven't showed you calculator logs. And there are a couple ways to deal with scientific notation. One is to make it a decimal. So if you move this into a decimal, you can type that in. So on your calculator, there's a log button on the left. This is log. Log 1 divided by this decimal. Close your parentheses and hit enter. You should get 8.1. Double. Keep something wrong. Log. So common log space 10. Okay. Good. Okay. Continuing on using your calculators. There are a couple ways to deal with these. You can just type those right in, and it should bring up the appropriate answer. So if you're given a calculator, that's what I suggest. Just type it in, let the machine do the work. Okay. So, anybody got an answer for that one? Approximately 1.6. How many? 3 decimals. 1.6. Okay. You can also simplify these by hand using the properties of logs. And I want to go through that just to show you what that might look like. What can I do with an exponent? Do you remember? Yeah, you bring it up front. What can I do with 2 items that are multiplied together? You can split them and add, right? Okay, so if you take that process, so 3 is not with the 5. Okay, so be careful there.
No.
So the 2 and the 5, you can split it and add, and then the 2 has that exponent of 3, you can bring it up front. It will get you the same answer in the calculator. Okay, but I just want to reiterate those properties. You'll have similar situation with this one, where you can just type it in. Or you can split it. What does divide mean? Yeah, you can subtract. So we'll have 2 log 19 minus log 2. Anybody have that in there? Get used to the 3 decimal rule. That's the AP Math standard. So for calc or stats, 3 decimals is the standard. So you can do that. And that will occur if these numbers will not, you can't calculate those logs very easily without a table or a calculator. I don't even think they publish the tables anymore in the books, but we used to have to flip into the back of the book and look up log 19. Get a decimal, multiply it, look up log 2, get a decimal, subtract. We had to do all those steps here. This splits it out. Here's an example. Yeah. Here's an example of a non-calculator. So we're going to give you the log 7 is 0.845. 1. So that's your given information. What is the log of 7 million? So your goal here would be to split it into a power of 10 and something with 7. So I can do 7 times what? 1 million, right? Now you can split them. Log 7 plus, and what is that as a power of 10? 6. We know log 7. What's log 10 to the 6th? 6. Remember, this is base 10. Those are inverses. They cancel each other out. And then you can add. So if you're given information such as the log 7, that's when you need to be able to know calculator piece. If I do not give you the information, such as here, you weren't given log 5 or log 2 or anything, that's when you're going to use the calculator. Okay. So, there you go. Okay, I'm good for today. Tomorrow we'll go over the change of base formula, another pH example, and solving exponentials using polynomials. Okay? We'll left you quite a bit of time to work. Honestly, 5 years.
Did we get graphs or anything?
Yeah, there's some graphs in there.
Like, we were on.
Probably both. I'll look. Okay, there you go. There's 17 to solve it by graphing. I'll show you that tomorrow. That's calculator friendly. Yeah, not a whole lot. Yeah, 66 is, but it says use a calculator. Yeah, either B is fine. Blocks are kind of difficult to get used to graphing, but once you get in there, it follows some pattern. If you need help, let me know. I'm gonna sit down and shake it pretty good, so just let me know if you need anything.
Okay. Let's do Thursday.